Hi, my name is Anna Kelly, and this is my design project for EE329. My design project is an alarm system. It consists of the MSP432 microcontroller integrated with a battery pack, a passive infrared sensor, an LCD module, a keypad, a digital to analog converter, and a red LED. When the alarm system is engaged, the PIR sensor acts as a motion detector. If the sensor detects motion, the alarm is tripped and the LED turns on. To deactivate the alarm, the user must input the correct 4-digit PIN using the keypad. To reset the alarm, the user must press the star key. The peripheral that I chose to utilize in this project is the passive infrared sensor. The PIR sensor acts as a motion detector by sensing changes in the infrared levels emitted by surrounding objects. The sensor produces an analog output which is sampled and converted using the ADC14. The alarm system software architecture has 4 stages: countdown, alarm engaged, intruder detected, and alarm deactivated. Before the countdown stage, the software architecture sets the default alarm system PIN, which is 1, 2, 3, 4, initializes SPI, and configures the DAC to output a DC voltage of 1 volt, turning off the LED. During the countdown stage, the software architecture initializes the LCD, clears the display, and sets the cursor at the beginning of the first line. The software architecture then displays the message, alarm engaging in, and a countdown from 10 to 1, with a half-second pause between each number. After the countdown stage comes the alarm engage stage. During the alarm engage stage, the software architecture clears the display and sets the cursor at the beginning of the first line. The software architecture then displays the message, alarm engaged. Next, the software architecture initializes the keypad and activates the motion sensor using ADC14 and its interrupt service routine. If the PIR sensor detects motion during the alarm engage stage, this triggers the intruder detected stage. During the intruder detected stage, the SPI is initialized and the DAC is configured to output a DC voltage of 3 volts, turning on the LED. Next, the software architecture initializes the LCD, clears the display, and sets the cursor at the beginning of the first line. The software architecture then displays the message intruder detected. Then, the software architecture reads the keypad input value. If a key is pressed, the software architecture records its value, clears the display, sets the cursor at the beginning of the first line, and displays the key on the LCD. This is repeated 4 times until a 4-digit keypad input is recorded. If the keypad input does not match the default PIN, then the intruder detected stage is repeated. The software architecture then compares the keypad input with the default PIN. If the keypad input matches the default PIN, this triggers the alarm deactivated stage. During the alarm deactivated stage, the SPI is initialized and the DAC is configured to output a DC voltage of 1 volt, turning off the LED. Next, the software architecture initializes the LCD, clears the display, and sets the cursor at the beginning of the first line. The software architecture then displays the message, alarm deactivated. Then the software architecture reads the keypad input value. If the star key is pressed, the alarm system resets and returns to the countdown stage. The alarm system has the dimensions of 31 centimeters by 14 centimeters. Its optimal operating temperature is between -40 and 85 degrees Celsius. It has a power supply voltage of 3.7 volts supplied by the battery pack. It has an average power consumption of 1.85 watts, and it has a battery life of approximately 2.4 hours. So, if I turn on the alarm system, it initializes to this screen. And since it has detected my motion, it goes to the intruder detected phase. And then if I type in the wrong PIN, it remains in the intruder detected phase. And then if I input the correct PIN, it it goes to the alarm deactivated stage. And then if I press the star key, it resets.